Hello, my dear students. Welcome you all. Welcome to Unacademy. This is your B V Reddy sir. A great news to all of you. I am going to start the YouTube series of lectures to cover each and every problems of networks. Yes, and I am planning to discuss all the problems of DPP and which will include all the PYQs. It will include all the PYQs of ECE, electrical, and as well as instrumentation. And this course, what I am planning, this series of lectures, it is helpful for all the three branches. And अगर कोई doubt हुआ तो भी you can do message me so that I will discuss those problems. Right. So in this now first I am planning to discuss the first chapter, that is basics. Thereafter I will do the theorems, transients, two-port networks, AC circuits. Right. चलो आज का सेशन हम शुरू करेगा. And before this we have one great announcement. In GATE 2024, 7 AIR ranks from Unacademy students only. 7 ranks, that those are electrical, CSIT, ECE, CH, IN, PI and NM. All these different branches Unacademy students have performed very nicely, and the result itself will show that how good the educators, how the system is working. Right, you can start your serious preparation with the Unacademy to achieve your dream jobs, dream goals. इसके लिए we are और भी बढ़िया ऑफर आपके लिए आई. Yes, that is flat 50% of discount for GATE 2025 के लिए. That is just 9999 only, and this is a limited period offer. Utilize this offer before going to expire. So you can find the top educators team in a single frame. So to enroll for this, you can use a code of B V Reddy. So by using the code of B V Reddy, you will get the great offers आपको मिलेगा. Utilize this opportunity and you will have a great learning experience from the top educators. And so this plus subscription is 9999 iconic के लिए. So here 15,999. So do enroll for these courses and to have a great learning experience from the Unacademy top educators. चलिए आज का सेशन हम शुरू करेगा. चलो, take the first problem. So I will try to solve each and every problem. So here you can copy the problem and everybody try to solve the problems. चलिए, take the first problem. If R equivalent equal to given as 50 ohms, they are asking to find the value of R. This value they are asking to find. So first of all, you tell me now how these three resistors are now in parallel. In parallel case, the equivalent is what we can say. Tell me. So this is which is equal to 12 by 3. So that means how much this value? 4 ohms. Now this R, this 4 and 10 are in series. So I will becomes what? Tell me now here. This is R plus 14. Now, so now you can tell me now here this equivalent is what we can say. Tell me where this R equivalent, that is given as this 30 plus and 60 and R plus 14 which are in series. Now you can tell me now here R60 and R plus 14 parallel, we can get it as like this now. So R equivalent which is equal to 30 plus what I can say 60 into R plus 14 by 60 plus, that means R plus 74. R equivalent is given as 50, given here, substitute the value. So that is 50 equal to what I can say. Tell me 30 plus 60 into R plus 14 by what I can say. Tell me now here R plus 74. Simplify these two here. Now I will cancel the zeros now here. 5 minus 3, 2. 2 is equal to what I can say 6 into R plus 14 by, that is R plus 74. So tell me now 2, this is 3's. So what I'll get, tell me now here, R plus 74, which is equal to what, tell me now, 3R plus what, tell me now, 42. So then 2R, which is equal to what, tell me now, 74 minus 42. Yes, simplify these values, check the value of R, how much will come. So this is R value, which will come it as what, tell me now, 16 ohms. Next problem. Calculate the equivalent resistance RAB at the terminals A and B. Now you can see now, first of all, these two are in series. How much this value, tell me now here, this value 8. And this 8 and 8 are parallel, will becomes 4. 4 and 4 are parallel, will become 2. So that means you can tell me now the equivalent. So here this is A. This value how much you tell me now? 2. And this value how much we got now? 2. Now you tell me now here 10 10, which is a 5. 5 and 5, that is 5 by 2, that is 2.5. And this point is B. Now you can tell me now here RAB. So which will come it as what, tell me? So that is 2 plus series now 2.5. So that means RAB will come it as what, tell me? 6.5 ohms. Student, calculate the equivalent resistance across AB. Now you can tell me now how these two are. Tell me first of all, 20, 30. These two are parallel. Equivalent is what we can say, tell me. So 20 into 30 by 20 plus 30. So which is equal to 50. So this 0 cancel here. This is 5 fourths. That means this value is at 12. 12 and 8 is in series. Will become 20. 20 and 5 are in parallel. So that means what I can say, RAB is a, that is 5 parallel to 20. So that will becomes what, tell me now here, 20 by 5. So will be how much you tell me now, 4 ohms. Next. Now you can see now here, in this case, how these two are, tell me now here, parallel, will becomes 20 parallel to 5. So it will be, so 4 ohms. This combination, this is 4. And how these two are, tell me, parallel. So this value is what, tell me now, 40 by 5. That means which is equal to 8. So now you tell me now here RAB. So which will come it as what, tell me now, 4 plus 8. That is what, tell me now, 12. Next one. Calculate the resistance RAB. Now tell me now here 3 are parallel. So let us do the 2 2. Then it is easy. So first I am doing these two here. 20 and 30 parallel. So it is 20 into 30 by 20 plus 30. So that is 50. So that means what now here? 5 fourths now here. So this value 12. Now this 12 and 60 are in parallel, right? So this value will becomes what, tell me now here. So that is, so 60 parallel to 12. So here, so this will be, so here 60 by, so here 5 plus 1 6. So this value is 10. Now this 10 and 10 are series 20. So finally what happens now here, RAB, which will be what we can say now here, 80 parallel to 20. Check this thing all of you. So this value will becomes what, tell me now, 80 by 4 plus 1 5. So this will be given as what terminal 16. Next, calculate the equivalent resistance between A and B. Now see the circuit now here. Whenever you are not able to identify the connections, so then what we can do here, simply take the terminals and start redrawing the circuit. So you can tell me now here, this point is A. So this one in between here, from here to here, there is no element, right? So that's why this is also point A only. And this whole point is what, tell me now, single point only now, this is B. And let us call this is C. Now let's redraw the circuit now by taking the terminals now here. This I am calling it as A, this is C, and this is B. Now you can tell me now between A to C this resistance is there now. How much this value, tell me, which is equal to 5 ohms. And this is B to C. B to C this resistance. How much this value, tell me now, 2 ohms. And A to C. A to C this resistance now. How much this value, 20. Tell me now here. So here these two. How these two are, tell me now here. These two are parallel. Will becomes what, tell me now here. 20 parallel to here. So it will be A. Oh, one more resistance is there. Okay, this is there now. A to B. A to B means where? Here. Resistance is there now. This is A to B. What is value? 3 ohms. Now you tell me now here how these two are parallel. Will becomes what, tell me now, 4 now. And this is 4 and 2 are series. Will be 6. Now tell me now what is this RAB? Tell me now here. That is 6 parallel to 3. So we'll come it as what, tell me now here, 2 ohms. Next. Tell me now here how these are. Now you can see first of all these two are parallel. Parallel, how much this value will becomes now here. So this is 20. We have seen, I think so. This is already 20 into 30 by 50. So this 0 will get cancelled. 5 fourths now here. So then this value is at 12. So means this value which is equal to 12. And what about this value, tell me? What about these values now here? 10 and 40 are parallel. So it will becomes what now? 40 by 5. Means this is equal to what, tell me now here? 40 by 5. This is equal to 8. Now this 8 and 12 also parallel. So we'll come it as what, tell me now here? 8 into 12 by 8 plus 12 is a 20. So 4 twos, 4 fives. So this value is what, tell me now? 24 by 5. And this value is what, tell me now here finally. So this RAB will come it as what, tell me now? 55 plus what, tell me now? 24 by 5. Yes. Simplify. See what I will get this value. 59.8 ohms. Next. Find RAD, AB, AC, BC. Now this is called as a lattice network. This is called as what? Lattice network. Now see this thing, how we need to solve this type of problem. First, we need to get what element of RAD, right? So if I redraw this part, you can observe here carefully. right? This is A and this is given C, this is given B, this is given D. Now you need to observe here carefully what we require. Now A to D required only C, only A to D only. Here the values given as 1, this value given as a 2, this is given as a 3, and this is given as a 4. Now wherever we required, there only will take the terminals. Now here A to D required now, so make it as only A to D terminals, and remaining extra terminals are there now, so you can remove them simply. Okay. Now you see this thing here. So A to D, the current is started at A, and the same current has to end at D, has to end. This current has to end at D, right? Now you see this thing carefully. Now this current, after coming to the junction, so some current will go here. This current is what, tell me now, I1. And some other current will go here. This current is what, tell me now here. This current is I2. Right. Now you tell me now this current I1 which is going like this, and this is going like this, and so this I1 which is going like this. Now see, you see this thing here, the current of this resistor 1, 3, 4 is same current is passing. That means how the connection I can say, series connection. So from this what I can say now here, that is RAD. It should be given as what I can say, tell me. So this is 1 plus 3 plus 4, and that is in parallel. That is in parallel to what, tell me now here, 2. So tell me now here how much this value of RAD. So this value 6 parallel to 2. Simply we can simplify it now here. So this value is 8 by 5. Got it? Understood the thing, what I need to do. Now look at now here, next one is a, next one we can directly write now here. I need to find what now here, RAB. That means A to B we need to see. Come into here, this is the current I started. Now the finally the same current has to return to here. That means in this one current must be 0. So D also current must be 0, right? Now after reaching here, some current is going here. This current is I1, and this current is what, tell me now here, I2. Yeah, you tell me now here, the current which is going in this path I1, I1, I1. So here has to return back to here only now. In this path will finally reach the destination. That means how this 1 and 3 are in series. So that means what we can say, that is 1 plus 3 series. We can directly add now. And what about this resistor? This resistor current is I2. I2 coming like this. After coming, the current will come to here now. So this how the 2 and 4 are same current is passing. So that's why it is series. So parallel to what I can say, tell me now here, 2 plus 4. Is it fine? That's all. So simplify, how much is value, tell me? 2.4 ohms. Next you tell me now here RAC. Now tell me now A to C. A to C. So current will start at A and finally end at C. So B and D no current. Now you can tell me now this current must be a I. Now you can see now here, the after current reaching here, some current will go here. This current is I1 and this current is I2. Now you can tell me now here, this I1 complete सीधा इस path में जाएगा, but this I2 current will come like this. After reaching here, has to come like this, doesn't go to B, and finally will come to where, tell me, C like this. So the current through this 2, 4, 3 are same only. So means what we can say, those are in parallel. That is 1 parallel to what we can say, tell me, 2 plus 4 plus 3. So how much this value, tell me here, which will be equal to 0.9 ohms. Next, RBC. Now here the current has to start from where, now here B, and final point must be C. So look at now, started at B and finally come to here, destination is C. So C, here there is no flow of current, and here also there is no flow of current, right? Now tell me, now current will started here, some current will go in this branch, this current is I1 and this current is I2. So now this I1 go like this, after this like this, and after this like this will go like this. Same current is passing through the, what, tell me now here, 4 plus 2 plus 1 parallel to what, tell me now here, this is 1. So this value now here, understood the way of approach. So this is what, tell me, 3 now. How much this value? This is 3 now. 2, 1 and this is 3. So how much this value, tell me, 2.1 ohms. Next one. Find RAB of the following. So equivalent resistance of this following. One by one. Yeah, you can see now this point is A, right? This whole thing, this point is B now here. So there is no element here. So that is, this point is also B only. No element means same branch. This is B. Now let's see this thing one by one, resistance now here. So this point is A and this point is what element now, B. So now here between A to B this resistance, place it. Between A to B this resistance, this is R. Between A to B this resistance, we are placing it like this. This is another R. Between A to B this resistance, so place it. So this is R. So from this, what I can say, tell me now here, RAB, which is equal to what, tell me how these three are parallel. Now tell me the second one here. So this point is A, this point is B, this point is also B only in a way because no element, and this point is also B only. So I can place now, this is A and this point is B. Place one by one resistor. This is from A to B. 4 resistors are there. In between A to B only. All the resistors are between A to B only now. All these values are same. Right. All are equal values only. So that's why. So what I can say, tell me now here, RAB is what, tell me, R by 4. Next. Now. So tell me this one also. Now this point is A and this point is B. Now here in between this and this we have some element is there, that's why this should be taken something else. I am taking as C and this point is C. This point I am taking as C. Now you can tell me now here this point which will be a and this point is a C and this point is a B. Now you see this thing here. This is, we have these three resistors are between A to C. All the three resistors are between A to C only now here. A to C. This is also A to C and this is also A to C only. So this is R, R and R. And these two resistors are between C to B. C to B now here like this. This is R and this is R. So now you can tell me now here. So what is the equivalent of these three, which is R by 3, and this part is what, tell me now here, R by 2. Finally, what we can say now here, RAB, which is equal to what, tell me now here, R by 3 plus R by 2 series. Now that is what, tell me, 5R by 6. Next one. The equivalent resistance between the terminals A and B is equivalent resistance between the terminals A and B. Here there is no connection, this connection like this. Okay, one over other. No connection, no direct connections. Now tell me what we can do here. Now this point is A and this point is B. Right. So this point, if I call the C, this point is a D. Now this point I am calling it as a E. So this point is also E only and this point is also E only. Yes or no? All points same only now. Now you can see now how these two values are series. I can redraw this part. Tell me now here, if I redraw this part, here this point is A and this point is C. Between C to D, this is C to D. So this value 1 and this value 2, and you can see now here this one between, so, and this point is E and B. So this point is what I will B. How much this value? 0.8. So this point is E and this whole thing is E only, this line. Now you see this thing between D to E, there is a resistance is there now. How much this value? Tell me now, this value 2. Next D to E only. So this resistance is also between D to E only now here like this. D to E. How much this value? 6. Next. This is between C to E. C and this is E now here like this. How much this value? C to E value. How much it is? 6. And this is also C to E only. So place it now. C to E means here only now. How much this value? 3 ohms. Right. Now you can tell me now how these two are now here parallel. So 6 into 3, 6 into 2 by 6 and 2. 2 or 3, this one 2 only. Okay, fine. All are completed only now. So fine. One more 3 is there now. This is 1 second. Here D to E, this also there now. There is another one here between D to E. So means here there is one more resistor is there. So this value how much here? 3. Okay, so that means what I will do here first, these two I am doing here. I am doing these two first. Okay, easy purpose. This value, right. So this value which is a 3 and this value is a 6 and here this is a 2. Hmm. Now you tell me now how these two are parallel. So 3 and 6 parallel means what? Tell me 2. 2 are how much it is a 1. 1 and 3. So this whole value, so this value 1 and 2, so this whole value is a 3. And this whole value is how much you tell me now? 2. These two are parallel. So means what happens now here finally RAB will come it as 1 plus these two, how much we can say now here? 2 parallel to 3 and plus what we can say now, this is 0.8. So this is RAB which is equal to 1 plus 2 into 3 by 2 plus 3. So that is 6 by 5 plus what we can say now, this is 0.8. So that's why it is RAB equal to 1 plus 1.2 plus 0.8. So then we can say this is RAB which is equal to what? Tell me now here, 3 ohms. Okay. Next one. They ask him to find the equivalent resistance between A and B. Right. Now you can tell me now here. Here we can do the symmetry analysis. If I draw a line like this, about this line, so the network is symmetrical now, so it is perpendicular to AB. So that's why this network has what symmetry? Tell me, perpendicular symmetry. This has a perpendicular symmetry. In case of perpendicular symmetry, the condition is what? Tell me, the current passing through the overlapping branches must be same. So if I call this current is I, so this current must be also I only. Same current has to flow. Now you can see now here in this branch, so कुछ current इधर जाएगा. This current, if I call it as I1, when I fold it now here, this branch, when I overlap like this, so then this branch should overlap with this fellow, right? So that's why this current, which I am calling it as I1. Next, if I call this current is I2, now this current is also I2. Now this is what I'll be now here. Yes, when I fold it now here, this branch will overlap with this branch. That's my same current. This current, if I call it as I3, this branch will overlap with this branch now. So that's why this current must be also I3. Now you can see now here, this current is I2 coming like this current I2 and this current is I2 simply going like this. And this current is what? Tell me now here, I3, and this current is what? Tell me now here, I3. So this is I3, this is also I3 only now, tell me. So that means what you can observe here, there is no flow of current through this branch. If there is no current flowing through any element, then we can call that element as a dead element. This element is called as what? Tell me now, dead element. This dead element does not affect the circuit operation. So that's why we can disconnect the dead element from the network. And thereafter we can redraw the circuit. So by disconnecting that element, If I redraw, so then see the circuit how it will becomes. Now you can see now this is R, this is R, this is R. Right. Now you can see now here how this and this, these two are in series. 2R. And this is also 2R. And 2R and R are parallel. 2R parallel will becomes R. Yes. So then it will becomes what, tell me now here? It will becomes R by 2 finally. How much you tell me now here? RAB, that is equal to R by 2. Right. Next. Now you tell me this thing. Find RAB, equivalent resistance between A and B. A to B. So same thing here. So about this line, I can say the network is symmetrical now. So what type of symmetry you tell me now? Perpendicular to AB line. So I will call this as what symmetry? Perpendicular symmetry. So this has what symmetry here? Perpendicular symmetry. If the network has a perpendicular symmetry, then see what happens now. Current passing through the overlapping branches is same. This current is I and this current is also I. Now, so from this, what we can say now, this current I'm calling it as a I1 and this current I'm calling it as a I2. Right. Next. So this current is I1 means this current is also I1 only. Overlapping now, this branch will overlap with this branch only now. Now this branch current is I2, then this current is also I2. Next. Now after reaching here, so what happens now here? Some current will go here. This current I'm calling it as I3. And this current I'm calling it as something I4. And this current I'm calling it as a I5. Now this is I5, this is also I5. And thereafter this is I3. When I fold it now here, this current is also I3 only now, folding. And this is I4 and this is also I4 only. So here you can observe the important thing is the current I1 which is coming like this, going like this. And this I3 coming like this and simply going like this. This I3 current not coming to this branch and I1 is not coming to this branch. Yes or no? So even though there is a connection seems to be there here, but there is no use of that connection now. That connection doesn't affect or not. Why? Because there is no flow of current. That is a dummy connection. Can I remove that connection now? Tell me. By removing that connection, I can redraw the circuit. So tell me now here. Right. Now all these values are same, so because of this connection what we have, this connection, I can remove this thing here. I'll make this as like this. Now tell me. Now you can tell me now here. All these values are equal only. Are right. Now you can see now here the problem solving will becomes easy now. Look at now here. And these two are, how much this value 2 are, and these two also 2 are. These two are 2 are. Right. Now you can tell me now here. These 2 are and these 2 are. So these two are parallel. So here will becomes R and R and R. This will becomes R by 2. Yes, the whole part of this part will becomes what I mean R by 2. Right. So now this R by 2 and R are in series. So finally what I'll get, tell me now here, RAB. So these are the 2 R. So parallel to what, tell me now here, that is 2R plus R by 2. Simplify and get it. So what will come here? This is 2R parallel to what, tell me now this is. So 5R na 5R by 2. So how much this value, tell me now, 5. It will be given as 10R by 9. So this is RAB. Right? This is the way we need to solve this type of symmetry problems. Next one. In the figure RA, RB, RC given, they ask him to find R1, R2, R3. So tell me now, nothing but what? Delta to star. So this R1 is here now. So this is here. And so this this is R1. And so this is what, tell me now here, R3. And this is what, tell me now, R2. So tell me now, R1 is what, tell me, R, that is in between RB and RC. So means what we can say, RB and RC, 10. So that is 10 into 10 by, this is sum is what, tell me now, 40. So we'll come it as what, tell me here, that is 5 by 2 ohms. Next, whatever the R2 now, tell me, between RA and RC. So RA value, yes, that is 20 into RC value 10 by 40. So this is 5. Next, R3 value, so RA, RB. So this is what I mean, 20 into 10 by 40. So this is what I mean of 5 ohms. So option A. Next. If each branch of a delta circuit has impedance root 3Z, then each branch of equivalent Y circuit has a impedance of same thing. Delta circuit, the impedance is given. Delta circuit, each branch impedance, they are saying it as what? Tell me. This one, each one having this value, each branch impedance. So this is given as root 3Z. This is also root 3Z. This is also root 3Z. Now they are asking what? Tell me now here. Corresponding star. So this star means from here will come one resistance now. Then all will come equally. Since all the delta values are equal only now. If I call this is something R1, if I say, tell me the R1 is now, just now we have seen now, product of this to root 3Z into what? Tell me now, root 3Z by what? Tell me now, sum of all. So this means what I will get now, root 3Z into how many are there? 3. So we'll come it as what? Tell me now here, that is root 3Z by 3. So we'll come it as what? Tell me now here, Z by root 3. Option A. Next one. The equivalent resistance they ask him to find. Now tell me the equivalent resistance now here. Whenever the cross connections are there, what we can do? Redraw the circuit. So this I am calling it as A, this is B, this point is C, so this point is also C only. If I have taken this point is D, this point is also D only. Now place it one by one here. You can see the connections. Since generally 4 are there, we'll go for the bridge form. Now let us try to form a bridge now here. Look at now how it should be. Nodes are there now, so let's go for the bridge form. This I'm calling it as A, B, this is C, this is D. Right. Now you can see now between A to C, how much this resistance is given, you tell me. This is 2. Next C to D. C to D means here now this value given as what? Tell me, 25. Next D to C. D to C also C to D. Both are same only now. How much is value given? And draw it a little bigger one. So here this point is A, this point is C, this point is D, this point is B. Now tell me now A to C, the resistance is how much? You tell me now, 2. Next this is C to D. How much is value? 25. This value 25. And this is also C to D only. How much is value? 50. Two resistors now here. This is 50. And what about this thing? This is also 50. D to C. This is a 50. Next D to B. So this is what we can say. Tell me now here. This is 8 ohms. Now here these two are 50, 50, 25, 25, 25 parallel will becomes what? Tell me now here, 25 by 2. So then that is what we can say now, this RAB, which will be what? Tell me now, 2 plus 25 by 2 plus 8. So this is RAB, which will come it as what? Tell me, 22.5 ohms. Next, consider the star network shown in the figure. The resistance between the terminals A and B when C is open given as like this. Okay. Resistance between the terminals where they given of A and B means resistance between A and B. So that is given as what terminal RA plus RB. How much their value given as 6. Yes. Next, between B and C, RA plus RB. So they given this as 6. Between where now here B and C. So that means what terminal RB plus RC, which is equal to what terminal 11. Next, between A and B. So that is between C and A. Sorry, that is RC plus RA, which is equal to what element? 9. Now, if I add all, so tell me what I will get now here. 2 times will come now. 2 into RA plus RB plus RC, which is equal to how much now here? 20, 26. 26. Yeah, from this what I can say, tell me now RA plus RB plus RC, which is equal to 30. Now if I say this is equation 1, this is second equation, this is third equation, and this is fourth equation. Now from this 1 and 4 minus 1 if I do, so that is equation 4 minus equation 1 if I do, it will give what tell me now here? RC will come. That is RC is what tell me now here? 13 minus 6, which is equal to what tell me now? 7. And if I do 4 minus 2 if I do, that means will come it as RA will come. RA is what tell me? So 13 minus 11, which is equal to what tell me now? 2. Next 4 minus 3. So tell me what will get, tell me now, this is RB will come. RB is what, tell me now here? 13 minus 9. So which is equal to 4. So the option B. Next. All resistors in the figure are 5. They are asking to find the equivalent resistance. Means this is 5. All the values are 5 only. No? Right now you tell me now 5 and 5 are series will become 10. 10 and 5 are what, tell me? So this is 10 and 5 are parallel. 10 parallel to 5, which will come it as what, tell me now? 10 by 3. 10 by 3 and 5 are in series. So that is 10 by 3 plus what, tell me now? 5. Will come 15 plus 10. So this is 25 by 3. Right. 25 by 3 and this 5 parallel. So this is 25 by 3 parallel to 5. So we'll come it as what, tell me now? 25 by 5 plus 3, 8. And 8. So this is what we can say now, this R equivalent is now 25 by 8 plus what, tell me now? 5. So I will come it as 25 plus, so 40 by 8. So I will come it as what I mean 65 by 8 ohms. Okay. Next one. So R equivalent resistance is you tell me now these two are in series, so 180 plus 60, so which will be a 240. 240, this 240 and this 60, these are in parallel. So I will commit as what, tell me now here. So 240 parallel to 60. So multiply with 4. So we will commit as what, tell me now? 240 by what, tell me now here, 5. 4 plus 1, 5. So we'll come it as what, tell me now, 5. 5 fours, 8, 48. And this, from this R equivalent is what we can say now here, 25 plus 48. So how much this value, tell me, which is equal to 73 ohms. Next one. Yes, find the equivalent resistance. Now tell me now, 60, 80, 20 are in series. How much here? 100, 160. And 160 and 160 will be 80. 80. So this is 80 plus 28 plus 52. How much this value, tell me now here? So this value, again it is 160 now, tell me. 160 and 160 are in series, sorry, parallel. So 160 parallel to 160, which will be a 80. 80 and 20. 80 and 20 series. So finally what I will get to, tell me now here? R equivalent, which is equal to 100 ohms. Okay. Next one. Now you tell me now this thing. How these two are 12 and 6 are in parallel. How much this value here? 12 by 3, which is equal to 4. 4, yes. And so how we can do here? This 4 and this thing will be connected here. So then these two are in parallel. So it will becomes what, tell me now, 80 by 4 plus 1, 5. So this value 16 here. So if you redraw this part of the circuit, tell me how it could be a. Here this is 2.5 ohms and this is 15 ohms. This value, which is equal to 4 ohms. This value 16, and this one, this resistance 60, which is from where to where now, from this point to this point, all are same only now. So I can place this value here. Here we can place it now here. This value, how much it is? 60. Okay. Now tell me now here. So these two are in series, will be 20. So, and you can tell me now here, 20 parallel to 60. So we'll come it as what, tell me now, 60 by, so 3 plus 1, 4. So here 15. Okay, 15 parallel will becomes what, is 7.5. 7.5 and 2.5. So these are in series. So then R equivalent will come it as what, tell me now here, 2.5 plus 7.5. So will be how much this value? 10 ohms. Fine. Okay. So that's for the today's sessions, and the next session will continue the remaining problems. Okay then. See you. Bye bye. And do follow this series of lectures. We solve all the problems we can solve it.